So the lowest value is -4. What's the highest value? +4. So the range goes from -4 to +4. Again, brackets on both ends because we're including those points, those y values. Because there's an ordered pair that actually has -4 as the y value, and there's an ordered pair, at least one ordered pair, that has +4 as the y values for that one. Okay. If we did interval notation, that's what it is. If we do set notation, instead of x, it's a range, so we're doing y values. What would be the inequality that would help us say from -4 to +4? And I think what I did on number 3 there with the domain. Less than or equal to y less than or equal to 4. Same idea there. And here's an interesting question that sometimes gets thrown in there. It says, how many times would y equals -2 intercept the graph? Y equals -2. What does it's saying how many times would that intercept the graph? So it must be talking about y equals -2 as a line. Where is y equals -2 as a line? It's not drawn there, is it? Where would it be if we did draw it? Yeah, horizontal line straight across right here at -2, right? You can go down to -2 on the y-axis, draw a line straight across. So I'm going to do that here so we can just physically see it. How many places does that cross? 4 spots there. It didn't ask for what 4 spots. It just said how many times. So you can visualize that. You can actually draw it on there. It's 4 times that it's going to cross that. And as for how many, what the exact spots were, we would have to estimate there anyway if we were going to do that if we don't have the equation. If we've got the equation, we can do a little bit more algebra to get there. But H go there. Where is f of x greater than 0? Let's think about what that question is asking. Where is f of x greater than 0? What's f of x? Somebody whispered it. It's the y values, right? So it's asking where are the y values greater than 0 in that graph? If they're greater than 0, what kind of number are they? Positive. So where are the positive numbers on that graph for y? On top. Yeah, they're above the x-axis, right? So there's this place, and this place where y is greater than 0. Now, how do you tell me that's going on? Interval notation is how you're going to tell me that. So what would be the interval for 0,4 to pi/2, 0? Well, it's the interval notation for that. And remember, here's what you've got to remember when you do a problem like this, is you're reporting x values. The intervals that you tell me are x values. That's telling me where to look left to right on the graph. So if they're asking where's y greater than 0, they're asking for what x values have y values that are positive. Okay, so the interval from 0 to pi/2, how do we write that? We write it bracket 0 to pi/2. Is pi/2 included? Back at the graph. What's the y value for pi/2? Is 0 greater than 0? No. So that means that doesn't fit the inequality. So that should not be included. So what do we put there if it's not included? Parentheses. That's one of the intervals where the y values are greater than 0. Let's get the next interval. And we're not putting a union here. We're listing individual intervals here. So I'm just going to put a comma. And then what's the next interval on our graph where y is greater than 0? Where's the next place where y is 0? So we're here, like we're reading the graph left to right. We've traveled down to here. Down here, all the y values are what kind? They're all negative down here, so I'm going up to here. Where do they start becoming positive? At 3 pi over 2. Does that include 3 pi over 2? No. So we're going from 3 pi over 2. Everybody's positive, everybody's positive, still positive, still positive, still positive, still positive, still positive, 0. So from 3 pi over 2 to 5 pi over 2 there. X values again, we're reporting X values. So is 3 pi over 2 included? Is 5 pi over 2 included? No, because their y values are not greater than 0. They're equal to 0. So we can't include them. So 3 pi over 2, 3 pi over 2 to 5 pi over 2. Okay. I think there's one more interval where the y values are greater than 0. We've read it all the way across to here. What happens to the y values to the right of 5 pi over 2? All these are negative, right? So down here below that, below the x-axis, it's negative. Where does it start being positive again? At 7 pi over 2 and going to where? 4 pi. And we stop at 4 pi because the graph stops there. If it had an arrow on the end of it, we would go to infinity. But it doesn't. It stops there at 4 pi. So what's that interval? How do we write that? Bracket the 4 pi, and what was the first number? 7 pi over 2. Yeah. Intervals are what you're reporting there. You're looking at y values, but you're reporting your x values with intervals. Okay. Question 7 that we're asking about this, they won't ask all of these questions about every problem. Okay, well, that's what I want you to understand. This is just, I'm asking a lot of questions about this same example. The idea kind of carries across to a very wide range of different kinds of functions. Where is f of x equal to negative 4? What's f of x again? Y. So that's asking the question, where's y equal to negative 4? Okay, what are those places? Good job. At x equals pi, and x equals 3 pi. Good job. Those are the two places where y is equal to negative 4, or f of x is equal to negative 4. Okay. Another question they might ask would be intercepts. What kind of intercepts do we look at in algebra classes? Y-intercepts. So that goes along with slope, like slope-intercept kind of idea. There's also x-intercepts. We did a lot with x-intercepts in Algebra 2. I know, because you do those higher degree polynomials, you got to find all the x-intercepts for them. There's a lot of work involved. So there are x-intercepts and there are y-intercepts. And we need to find them both. So we look at that graph. It's nice when we've got a graph to go with, because all we got to do is look at it and say, okay, where's it hitting the y-axis? At 0, 4. So the y-intercept is at 0, 4. Why is that? Yeah, the next example, we don't have a graph. We got an equation. But it's still not too bad. So how many y-intercepts are there when we look at that graph? Just one y-intercept, but there are how many x-intercepts? 4. 4 x-intercepts, because we can see it crossing the x-axis 4 times there. So then we just list those x-intercepts. Where's it crossing the x-axis? At pi over 2, 0, 3 pi over 2, 0, 5 pi over 2, 0, and 7 pi over 2, 0. We're going to list those. over 2, 0. 3 pi over 2, 0. 5 pi over 2, 0. And then 7 pi over 2, 0. We've listed the x and y intercepts. One last thing before we go to this, another question about this particular problem. I'm going to just put it right there. Intervals of increase and decrease. Intervals of increase and decrease. So this is one of those things, Tristan's saying slope was what reminded me I need to do this. But if you're increasing on a graph, what does that mean? What kind of slope does that mean you have? Positive slope. And positive slope goes which direction?
That way.
Up and to the right. Yeah, that way. Okay. Negative slope goes which way?
Down.
Down and to the right. That way, right? So if you're increasing, you're going up and to the right. If you're decreasing, you're going down and to the right. And you're always reading the graph left to right, just like you do a book, or like most of us do a book, right? So we're going to read left to right on this graph. And if we start here at the left, at 0, 4, what is the graph doing as we move to the right? It's decreasing until I get where? To pi negative 4, right? And then it turns around. So there's an interval of decrease, right? From 0, 4 to pi negative 4. Again, we're talking about intervals. So we're going to list the x values for that. So from 0 to pi, we're decreasing. So we'll put DEC for decreasing. And it's decreasing from 0 to pi. And at pi is where it's turning around. So we can't include pi in the decreasing of the interval. So we're going to put a parenthesis there. Okay. And then we'll also have a list of increasing, because what's it doing next on that graph? It's increasing from pi to where? Yes, sir. After we finish those. To 2 pi, right? Yeah. So from 0 to 2 pi. Or from pi to 2 pi, not 0. And then what's it doing after it gets to 2 pi? Decreasing again from 2 pi to where? 3 pi. And then from 3 pi, what's it doing next? Increasing up to 4 pi. And I guess technically we shouldn't have put a bracket right here because we don't know what it was doing before that. 0 may be a place where it turns around. In fact, it is. If you had the rest of the domain for that sine function. So let's just use parentheses only on increasing and decreasing intervals. Only use parentheses for those two. All right. All the other intervals that you do, you're going to look at bracket or parenthesis. On increasing and decreasing, parentheses only. Okay. All right. Example B, last one of the run here. They don't ask quite as many questions about it when they just give you the equation. Okay. They're going to ask some questions. Some of them we already know how to do. We did them in the last section. Like the first question here, what's the domain? So if our function is f of x is equal to x plus 1 over x plus 2. All right, so we set x plus 2 equal to 0 and solve it to find the domain. So x cannot be negative 2, right? So write that domain, set notation, And what would the interval notation for that be? There you go. Good job. So there's the domain in both forms. Perfect. Question 2 is a little trickier. It says, is the point, the ordered pair, 1, 1/2 on the graph of f of x? We don't have the graph of f of x. We do have a graphing calculator, but I think there's actually a better way to check it, because if you're looking at the graph on the graphing calculator, you're still going to have to kind of guess at it a little bit. What could we do to verify a certain ordered pair is on a graph? See if the x and y match up when I plug in the x, right? So if I find f of 1, if it's on the graph, what should that value be, that function value? If it's on the graph, it should be 1/2. If it's not, it'll be anything else. So I'm going to plug that in. 1 plus 1 over 1 plus 2. So that'd be 2 over 3, which is not 1/2. What's that tell us about that point? That it is not on the graph. That's a big no to that. All right. Another way to do that would be with your graphing calculator. I'm going to show you that because you got that tool. We ask you to rent one or have one. Let's use the thing, okay? I'm going to hit the y equals button. I'm going to clear out these other equations that I had from who knows when. To put that equation into your graphing calculator, I'm just going to go on y1, and I'm going to, in parentheses, put the numerator, x plus 1. X is right there beside alpha. You guys hopefully should know this. You used a, and then parentheses for the denominator. Very important that you put those in parentheses, else it won't read it the right way. Okay, and then hit graph, and you should get some sort of picture that looks like this. You can test that ordered pair by using the trace function on your calculator. The trace button is right there beside graph. You hit trace, and then type in the x value you want to find out about. We want to find out about 1, right? What's the y value there? 0.6 repeating, which we know is actually what fraction? It's 2/3, like we found algebraic. We did with algebra. We worked it out. Okay. There, that verifies that is not 1 1/2. Okay. We could check any other ordered pair like that. As long as it's within the screen, your calculator will use the trace function to check a value. If it's outside of the screen, depending on what model you've got, it kind of struggles with that sometimes, getting it outside of the screen. So you'd have to zoom out and then check, which is a little bit more. And in the time it takes to do that, we just plugged it in there and got it. It didn't take much time to do that. Okay. All right. Something your calculator is not very good at is checking y values. Really good at checking x values. It's not very good at checking y values. Where is f of x equal to 2? Notice I left a good bit of space there on purpose because we're going to need it. How do you check where y is equal to 2? You got to find out what x value goes with that. So how do you find the x value for a certain y value? Take the equation and set it equal to that y value. Because we have what f of x is. It's x plus 1 over x plus 2. But they say, okay, when is that equal to 2? So we take whatever f of x is and set it equal to 2. And then we've got an equation to solve. How do you solve such an equation? Multiply by x plus 2. That works. Whoops, no cancel on that side. Distribute. It's 2x plus 4. X plus 1. Now what? Subtract. Doesn't really matter what direction you go here. I'm going to subtract x and subtract 4. I'm going to do it in two steps in one shot there. There's x. 1 minus 4 would be negative 3. There is where f of x is equal to 2. The x value that goes with that is negative 3. Okay. So if they ask you where that's going on, that's how you're going to find that. Okay. Last thing for this particular section or notes on this section is the intercepts. How do we find, or what kind of intercepts did we find on example A? We found x-intercepts and y-intercepts. So we got to kind of go back to the fundamental idea of x-intercept and y-intercept from an 8th grade math class or a freshman Algebra 1 class. An x-intercept is where on a graph? It's on the x-axis, which would tell us that y values are what? 0 there. So to find an x-intercept, what do we do with the equation? Not set x to 0, set y to 0. So x plus 1 over x plus 2. That's what y is. It's this function. Set it equal to 0 and solve. That's nice because you solve it the same way we did the third part of this problem. You multiply by x plus 2 and you get 0 is equal to x plus 1. And then x would equal negative 1. So our x-intercept is at negative 1, 0. There's only one of them. If there are multiples, it'll show up here when you solve it. Okay. How do you find a y-intercept? Last thing. Set x to 0. So you find f of 0. 0 plus 1 over 0 plus 2. F of 0 is equal to 1/2. And there's that 1/2 y value that they were talking about in part 2. Okay. Suggested problems for this section on page 224 is where they start. 9 through 47. You go ahead and go. So 9 through 47 on. Tomorrow is a work day. We got about 20 minutes left in class today, not quite. So, you know, you can get started today if you want to. You got a work day tomorrow. If by chance, and they've increased the chances of wintry weather on Friday, if we are not here Friday, unfortunately, that means that when we come back on Tuesday, or whatever day we come back next, would be your quiz over section 3.2. Okay, so work day is tomorrow. We'll do that like normal. And then if we're here Friday, we take our quiz. There's a possibility that we come at 8 o'clock Friday and then maybe they dismiss it at 11:30, so it counts as a day and we don't, we'll use one of our weather days if they turn out at lunch. So that's a possibility. And we would meet and we'd have, even if we met with all 5 of our or 4 of our classes, we would still be able to get the quiz in on Friday. So if we are out on Friday, your quiz will be the next day we're in school. Okay, that's just the way it goes. I think I would trade off a couple of days extra off. You got a 3-day weekend this weekend anyway, so it's possible that it could be a 4 or 5-day weekend. You never know. So I wouldn't complain either. So, but anyway, work day tomorrow. You got about 20 minutes left in class. You guys can chill. Which one? The intercept? Okay. Anytime you're looking for this intercept, if you got the equation, you set the equation equal to 0 because you're setting y equal to 0. Because an x-intercept is, if you look back at the x-intercept goes through the x-axis, like so like on the here, since I got that.
So in order to do that, the y would have to be 0.
That's exactly right. And then to find y-intercepts, the y-intercept, the x's always have to be 0. So you're always going to plug in if you're trying to find x-intercepts, plug a 0 in for the other for y. If you're trying to find y-intercepts, it's a 0 for x.
That's why.
That's why here we plugged in a 0 for x there to get the y intercept. That's always going to be the case, no matter what kind of equation you have. Okay. Yes, ma'am.
You have Johnson back in.
Yeah.
Just check it out.
Okay.
Thank you.
Hey. Yes. Pass on this there. All right, Brett. That's fine. Well, just you got the notes and the assignment there. If you got questions, you can come in and ask. When we get back. How many people are going on the host? Is it a hosted trip that you're going on, or is it something totally different? Okay, competition thing. How many people are going to be out tomorrow? I know some people in my other classes said they weren't going to be here tomorrow, and Brett just said he wasn't either. So I was just curious because we don't get a list anymore. All right. Just a reminder, Megan, Grant, Emily Farrell, Addie, I think that's what your dad was in here taking care of, was that form. Colin, the parent permission form to take dual enrollment classes at Bethel. See Miss Bowen if you need another copy or need to talk to her about any of that. Just see Miss Bowen. She's kind of the go-to on all that stuff. So. Hey. Yeah, I should. Is it still locked out?